In this example, we are going to be finding the equation of a line tangent to the graph of this, so inverse secant of 2x at a particular point. So when we're doing this, at the end of the day, we are finding tangent line, which means we're finding a linear equation. All right, so that's kind of the process that we got going on. So far, we have a coordinate. We have an x, we have a y. What we don't have is the slope. That's where the calc kicks in. So we need to find the slope equation, i.e. the derivative. So we're going to be taking the derivative of this, and we're going to plug in our x value to find our slope, and then we can finish it off by creating our equation. So first thing is, let's do our derivative. When we're doing a secant, we have a formula for this. And so we're doing an inverse, and that is just our formula. It does have a chain rule applied to it. So we need to figure out what our u is and then plug things in and multiply by its derivative, the chain rule piece. So our u value is 2x. All right, so if we start plugging things in, our inverse secant is this formula. So we're going to do 1 over the absolute value of our u, which is 2x, and then times the square root of 2x squared minus 1, and then that's times the derivative of u, which is 2. All right, so there's our first part, is just kind of doing the derivative. So the calc's done. Now the algebra is going to kick in. So our algebra is, we're going to put the 2, actually that 2 in the denominator, because this could be an over 1. That 2 could simplify with that. This is going to become a 4x squared. So we're looking at a 1 over the absolute value of x times the square root of 4x squared minus 1. And then maybe we can simplify this. This would factor into a 2x plus 1 and a 2x minus 1. But since they don't match, we can't square root, we can't simplify. So that's it. That's our derivative. So very next thing is, let's find the slope at 1, right? So let's find our slope at 1. We have our slope equation. We just need to plug it in. So we're looking at a 1 over the absolute value of 1 times the square root of 4 times 1 squared minus 1. And that's going to equal, let's see, we got a 1 over absolute value of 1 is 1 times the square root of 4 minus 1 is 3. So we're looking at our slope at 1. Keep my good habits here. Our slope at 1 is 1 over root 3, which let's rationalize. So our slope is root 3 over 3. So that's our slope. So we're going to use that slope to finish off this equation. So we're going to take that slope, plug it in. We have our x value, we have our y value. So we're looking at a y minus our y value of pi over 3 equals our slope of root 3 over 3 times x minus 1. And then let's turn it into a y equals mx plus b. So we'll distribute. We're looking at a y, oops, too soon, y minus pi over 3 equals a root 3 over 3 x minus root 3 over 3. We're going to add pi over 3. And so our equation is a slope of root 3 over 3 x, and then let's do a plus a negative root 3 plus pi over 3. So I'm just kind of clumping that whole thing together with a common denominator. Be careful about that negative sign. If I left this as a negative, I would want this to be a positive and this to be a negative, because that negative technically would be distributing to both and then changing their signs. So to avoid that, I'll just always make that a positive and then keep those signs appropriately just left on those pieces. So that is our equation. Right, so that is us finding the line tangent to this equation at this particular point by us doing the derivative, plugging in the 1, and then coming up with our equation.